First of the screencasts that we're doing while I'm away at the conference. I want to set you up with where we stopped at the end, which was an example where we had two characters, Jamie over here on the left and the kids over here on the right. And what we did was we put together their production possibility sets for them. Each one of them is a constant opportunity cost production possibility set. You can see there are nice straight lines right here. And we've set it up so that using all of the resources and the technology available, that the Jamie character can produce at most 6 meals and can produce at most 4 clean rooms, and then you can do all these combinations in between. So remember, if it's along the frontier right here, what happens is that you can actually make it. It's feasible, but you've just barely run out of at least one of the resources. On the interior right here, those are combinations you can definitely make, and you still have stuff left over. When you're out here on the outside, these are things which are not feasible. You can't make these combinations at all. Anyway, so Jamie could produce at most 6 meals and 4 rooms. Children, on the other hand, these are the kids right here, they could produce at most 2 meals and 2 rooms. And the example we ended up with was that if they were separate, if they didn't engage in trade, if they were just going ahead and producing for their own consumption, that the Jamie character would produce right here in the middle. So he'd produce 3 meals and 2 clean rooms. The children, on the other hand, wouldn't care very much about the rooms, and so what they're going to do is produce right here, only producing meals. And I've depicted that over here in just this little table, which shows that here's a production and consumption plan. So Jamie actually produces 3 meals and also consumes 3 meals. Jamie makes 2 clean rooms and actually consumes those 2 clean rooms. And the kids produce just 2 clean meals. What we have down here is the joint production, what they produce, just adding it together. Now what I left you with was a puzzle. And the puzzle was come up with a production plan that produces more of both goods, or at least one good. And so the idea was to get some kind of specialization going on, and then make it so we actually produce more than 5 meals and more than 2 clean rooms. Now there's an infinite number of ways that you can do that, but there are a couple of ways that are just a little bit easier. And remember, the key to this is some kind of specialization. So what I'm going to do is propose directly the answer, and directly the answer is to have Jamie go ahead and make all meals. Okay, so this means that his production point, which used to be right here at 2 rooms and 3 meals, is sliding over to 6 meals and no rooms. Now the other part of it is to make it so that the children have also specialized. You see that before, when they weren't engaging in trade, they're producing 2 meals. Well, now let's go ahead and slide them all the way down over here to where they're going to be producing 2 rooms. And I'm just going to go ahead and fill this in over on this production plan table over here. Okay, so now I've filled in those production plans showing that, again, the Jamie character is producing 6 meals and no clean rooms, while the kids are producing no meals and 2 clean rooms. Now please note, you end up with total production of 6, which is more than what you had before, and total production of rooms of 2, which is exactly what you had before. Remember, the goal here is eventually to show that we can make somebody better off. Now, what we have to do is come up with something which is not just a production plan, but something which is a consumption plan that shows that somebody is better off. So what we have to do is make sure that one of the people gets what they had before, and another one gets more of at least one good. Now, the key to make sure that they're better off is to have it so that they have more of at least one good and the same amount of the others, or even more of the others. If you have more of one good and less of another good, you're really not sure whether you're better off or not. Now I've created another space down here for the consumption plan. So this is how we're supposed to allocate all this production, the 6 meals in these 2 rooms, in such a way that at least one person's better off. Now I keep things simple. I'm just going to make it so that we're going to try to make me better off. And so I'll go ahead and make it so that the kids get what they had before, which is just going to be 2 meals and no clean rooms. And then what we're going to do is just allocate the remainder of the production over to the Jamie character. So if the kids get 2 of the meals, we produce 6. That means that the Jamie character gets a total of 4, and we can take the remaining clean rooms, which are 2, and stick them over here. So what we've done here is now created a consumption plan that makes it so that the kids are as well off as they were before. Note that they have 2 meals and no rooms, just like they did without trade. And the Jamie character is better off because he has 4 meals, which is more than what he had before, and 2 clean rooms, which is exactly what he had before. So you know for sure he's better off. Remember, when we're talking about getting more stuff here, we usually have the assumption that's called free disposal, which means that if you don't necessarily want the good or want the cookie, you can always leave it on the plate and you're made no worse off by actually having it. So what we've done here is shown that by engaging a little bit of specialization, and then it's possible to swap goods back and forth, so at least one person is better off. Now, let me show you what I mean about you're not quite sure that you can be better off if you have more of one good than you had before and less of another good. Now what I've done is I've created a whole new consumption plan down here, and note that we have Jamie consuming 5 meals and the kids consuming 1 meal, which, still 6. This is still what we're producing. We also have it so that Jamie is consuming 1 clean room and the kids are consuming 1 clean room, which altogether is 2, is what we're producing. Now, we don't know for sure if Jamie or the kids would think of this as being better. If you think about it this way, you see the kids have this 1-1 consumption, which is something that was definitely possible without trade. But remember that without trade, looking around up here, the kids chose not to consume any clean rooms at all. All they wanted was meals. So instead of preferring this spot, they actually liked this one. And so what you can say is that the kids are probably going to be worse off with this consumption plan than they would with, say, this one. Now the Jamie character, you don't know for sure what's going on, because this is more meals and fewer rooms. Again, we can't tell for sure. Try to locate this particular point here on the production possibility set. You're going to find it's up here. It's not something that's feasible, so you can't make that direct kind of comparison. The main point that we're making with Jamie here is that while it's provable but that the kids are not better off with this bundle, you can't tell about Jamie. You need to know an awful lot more about Jamie. You need to know their preferences. And when you go ahead and take the next microeconomics course, this example gets expanded. You end up with some, I usually call them indifference curves that come through here. Oops. That will go ahead and show you how much people like things. And that'll be indifference curve analysis. Again, something you may enjoy in your intermediate micro class. So this is the end of the first screencast, and we will be expanding on this example in the next.